Good day and welcome to Big Bad Tech. I'm your instructor, Jim Pytel. Today's topic of discussion is hydraulic power units and reservoirs. Our objective is to examine the constituent elements of a generic hydraulic power unit and discuss those features in a reservoir that aid fluid conditioning in a hydraulic system. Central to the proper operation of all hydraulic systems are those components that source flow and condition fluid. At a basic level, a hydraulic power unit, sometimes called a hydraulic power pack, consists of a prime mover, a pump, and a reservoir. Additionally, most hydraulic power units include a pressure relief valve and a means of filtration, since these components are essential to the safe and efficient operation of the larger system. A hydraulic power unit can also include some ancillary or supporting elements, though not essential to the system, add some serious bling. Cool points go to hydraulic power units with integrated pressure gauges, flow meters, heat exchangers like heaters and coolers, offline or kidney loop filtration units, and sensory apparatus like pressure and floater level switches and temperature sensors. Finally, a hydraulic power unit may also include lockout and tagout devices like shutoff valves or electrical shutoffs. You're probably familiar with most of these elements already, but since they perform essential roles, let's do a brief review. A prime mover is either an electric motor or gas-powered internal combustion engine whose responsibilities convert one form of input, electricity in the case of a motor, and chemical energy in the case of an internal combustion engine, into rotational mechanical output. Rotational mechanical output is characterized by a rotational speed, often measured in units of RPM, and a twisting force known as torque, often measured in units of Newton meters or foot-pounds force. The relationship of torque, rotational speed, and mechanical power as it relates to electric motors is explored in other supporting lectures at the Big Bad Tech channel. The rotational mechanical output of the prime mover is used to turn the drive shaft of a pump, ordinarily a gear, vane, or piston pump. Pumps, regardless of the type, convert rotational mechanical power into fluid flow, a quantity calculable by multiplying the volumetric displacement per revolution times the number of revolutions per unit time. It should be noted that very rarely are the drive shaft of the prime mover and pump directly coupled together, but rather this interaction occurs through the means of an intermediary coupling. The coupling's purpose is to compensate for shaft misalignment between the prime mover and pump and allow a technician to take the pair apart for repair or services. The reservoir, or tank, is the combined source and destination of all fluid flow for a closed hydraulic system. Positive displacement pumps create a vacuum in the suction line and actively draw fluid in from the reservoir. Pressurized flow is routed to the business end of the hydraulic system, being the valves and actuators that perform the required work, and return flow is exhausted back to the tank. At a very basic level, the reservoir's function is to ensure a ready supply of fluid is available to the system at all times. We'll examine other important functions of the reservoir in a moment. How these three basic components, the prime mover, pump, and reservoir, are physically arranged with one another dictate the outward appearance of the hydraulic power unit. Ordinarily, the prime mover is outside the reservoir. However, the pump could either be external or internal to the reservoir. The pump and prime mover can both be horizontally mounted on top of the reservoir. Additionally, the prime mover and pump can be vertically mounted on the reservoir. Here's an example of a vertically mounted configuration with a pump internal to the reservoir. When partially disassembled, you can see the pump. The prime mover and pump can also be mounted to the side of the reservoir, as is often the case for small hydraulic power units. Here's a cutaway example of a side-by-side configuration showing the external motor and the pump inside the reservoir. Finally, the prime mover and pump can actually be mounted underneath the reservoir. These various mounting schemes can influence the degree of aeration experienced in the suction line, with those pumps mounted to the side or underneath experiencing less should it occur. Aeration, if you recall, is the unintended introduction of air into the suction line of a pump. Hydraulic power units often include integrated pressure relief valves that may or may not be adjustable. A pressure relief valve is an essential safety device and limits maximum pressure of the system. When pressure exceeds the relief valve setting, either because of a closed valve position or the actuator having reached the limits of travel, the normally closed pressure relief valve opens and allows an alternative path back to the tank. Lacking a pressure relief valve, pressure could build to dangerous levels and possibly damage a hose, fitting, valve, actuator, or an operator. You'll note that a hydraulic system may be illustrated schematically with more than one reservoir symbol. However, this simply aids comprehension. There is only one reservoir. Rather than untangling a mess of intersecting and crossing return lines, a single reservoir can be best illustrated schematically multiple times. Additionally, hydraulic power units often include a return filter. A filter is a porous element, similar to a net, through which small holes allow the passage of particles smaller than the holes, however exclude and entrap those particles larger than the holes. Long story short, dirty liquid with suspended particles come in, and cleaner liquid with less suspended particles comes out. Any filter routed through the system must go through the return filter at low pressure prior to being emptied into the reservoir. The return filter's job is to remove contaminants from the larger system. The filter is often externally mounted on the hydraulic power unit inside a filter housing. The removable filter housing makes periodic filter changes a comparatively quick and painless affair. Here's a filter housing closed and opened. Most return filters include a clogged filter bypass and indicator external to the hydraulic power unit. A clogged filter bypass is essentially a check valve with a light biasing spring such that a fresh filter does not restrict flow and the bypass remains closed. If, however, the filter becomes clogged and a pressure differential develops across the clogged filter, the bypass opens, allowing the system to temporarily function without filtration. The bypass indicator warns an operator bypass has occurred, and it is incumbent upon the operator to initiate an orderly shutdown. A system operating for any length of time without the proper level of filtration is just asking for trouble. Here's an example of a hydraulic power unit with a clogged filter bypass indicator. Green means good to go, yellow means warning, about to bypass, red means no go, the filter is clogged and fully bypassed. Other indicators serve to display pertinent performance data, the two most common being pressure gauges and flow meters. A pressure gauge, sometimes called a manometer, indicates pressure at a specific point within a hydraulic system. As currently illustrated, this pressure gauge would indicate pressure at the outlet of the pump. Often a hydraulic power unit includes a single pressure gauge fixed at this important location. In contrast, a portable manometer making use of numerous quick disconnect inspection ports located throughout the system could take pressure readings at other points in the system. For example, this filter housing includes a quick disconnect inspection port on the return line of the filter. To take a reading with a portable manometer, the inspection port cover is removed and the portable manometer inserted. When properly seated, the check valves in both the quick disconnect port and the manometer are pushed off their seats to allow pressure reading to be taken. It is incumbent upon any technician taking a pressure reading to cover the port after use to prevent contaminants from being introduced into the system. A supplemental flow meter could also be used to visually indicate the flow rate to an operator or a technician. Simple flow meters are often orientation and direction dependent and cannot measure flow properly if mounted on their side, upside down, or when flow is routed counter to the desired direction. Meters like clogged filter bypass indicators, pressure gauges, and flow meters indicate basic hydraulic performance data for operators and technicians and can be used to facilitate the troubleshooting process. We'll examine other common indicators associated with reservoirs in a moment. Hydraulic power units may also include some additional bonus features like heat exchangers and offline or kidney loop filtration units. Heat exchangers like heaters and coolers can be used to condition fluid operated in extreme environmental conditions. A heater can be used to ensure that oil remains within a given viscosity range when operated in a cold environment. A cooler, in contrast, can be used to ensure oil does not thermally degrade.